We're going to check the refrigerant pressure on an AC window unit, and we're going to use this yellow jacket that we just got in the mail. And thread on your manifold hoses. I really like the thickness of the brass there. It's built very well. In order to get test ports in the air conditioning system, we installed these bullet valves. One on the high side and one on the low side. With the gauge closed, we'll open up our piercing valves. Now, as we open up the low side, we'll start to see pressures coming in the gauges. Without anything running, all the gauges are going to read the same. Right now, they're reading 150. Now we'll turn on the machine. Compressor kicked on. Start to see pressures building. It's been running for about 10 minutes, and both of the gauges are about 280. We'll shut it off. See, our pressure's dropping. When the machine is off, the pressures right here are called static pressures, and that's directly related to the outside temperature. So right now it's 88 degrees outside, and if we look at the temperature, just round up to 90 degrees, and then we go over to r410 vapor pressure, that's 108 psi. And you might look at the gauges and say that's way off, that's our problem. We have to think about solar loads. Right now the sun is shining on the pipes here and heating everything up. So we have to take account for that. On this brick right next to the machine, it's measuring about 120 degrees. This is getting the same amount of solar load that the machine is, and I can get an accurate reading. So that's kind of what the rough temperature that these pipes are being heated up to. So we need to take account. So about 120 degrees, we'll look at our chart and see where the PSI should be. If we look at the chart in Fahrenheit temperature, 120 degrees, then go over to r410 vapor pressure or liquid pressure. 195 is right where we're at on our gauges, and 176 is the vapor pressure. After reading our static pressure, we don't think that the refrigerant level is the problem. There's a valve here in the compressor that could be bad. Whenever the system powers up, the compressor turns on and starts building pressure. Both of the gauges build pressure at the same time, and they're both equal. They stay equal. So if there's a valve bad in the compressor, that would start to equalize the system. The ambient temperature outside is 91 degrees according to the temperature sensor on the air conditioning unit. And then this thermometer here says that the air that it's outputting is 90.3 degrees. So that's about 1.5 degrees that it's dropping the temperature. It's only taking it down roughly about 1 degree whenever it should be taking it down by about 10. You can see the pressures on the high and low side are almost identical. There's probably only 3 psi difference between them. Chances are the valve inside of the compressor is slowly deteriorated and allowed the system to equalize. By using these gauges, we're able to tell that the refrigerant level isn't the problem. The pressure itself is fine. It's where it's supposed to be. There's not a leak in our system. The pressure is equalizing. So if it's that valve in the compressor, we would need to completely replace the compressor. That's not something you can fix.